basis, there's only one set of weights that can be used to describe any particular vector. There's only one way to do it. It's not like there are two ways to describe the vector x. If we go back to this example that's still on the board, the column space of A is going to be equal to all linear combinations of those two vectors, right? Like C1, 1, 2, 6 plus C2, 2, 7, 6. Every possible real number assignment to C1 and C2 will give you an element of the column space. For instance, you can get 4, 11, 18, because that's also in the column space. There must be a linear combination of these two that will give you 4, 11, 18. And there's only one way to do it, right? The uniqueness is what this theorem is all about. Once you identify a value for C1 and C2 for a particular basis, there's no other way to do it. And so we call those the coordinates of the vector according to the particular basis we're talking about. So in this case, those weights C1 through Cn are called the coordinates of x relative to the basis b, or we say b coordinates. So a given vector has only one set of coordinates for a given basis, but you could have a different basis for the same vector space, and the vector will have different coordinates for that basis. And I think we're going to maybe talk about an exercise if we've got a couple minutes, because we're not going to go through that proof that you can read. The exercise at the bottom show that these three vectors, so 1, 1, 0, 0, 1, 1, and 1, 0, 1, is actually a basis for R3. And again, I don't want to barely have time to start. I'm just going to tell you what we're going to do next time. So what we got to show is that the span, so this will be next time. That the span of those three vectors, 1, 1, 0, 0, 1, 1, 1, 0, 1, is equal to R3. And we also have to show that these vectors are linearly independent. And so that's basis of R3. That's not the standard basis. We love 1, 0, 0, 0, 1, 0, 0, 0, 1 as our basis of R3. But we can also find other sets of vectors that are possible bases. And we'll get into all the details of that next time. So I'm done. See you Wednesday.